I built an MCP server in .NET that gives an AI agent real tools. So instead of asking why is my API slow, I can ask compare these two endpoints with 20 concurrent users and tell me which one performs better. And the AI can actually run that test without guessing, just run it. Today I want to show you something I think is much more useful than another chatbot demo. Because most AI coding demos look impressive till you ask one simple question. Can the AI actually do something with my real application? Not just explain code, not just generate a random minimal API or controller, but actually interact with my running .NET application, run a performance test, compare two endpoints, analyze the results, and tell me what is wrong. That's exactly what we are going to do in this video. Let me show what we are going to learn today and what I built here. In this video, I'm not going to explain every single detail of application. That would make this video way too long. Instead, I want to focus on the important part, the concept of MCP, and how you can use it in real .NET workflow. The demo application is already built in. It contains a sample .NET API with some intentionally slow endpoints. Also, it contains an MCP server that will be a main topic in this video. And it contains a Blazor dashboard that visualizes the results, and it contains another project which is shared models used between the services. So the goal is not let's build a full performance testing platform from scratch. The goal of this video is let's understand how MCP allows an AI agent to interact with real .NET applications. So what is MCP at all? MCP stands for Model Context Protocol. So the simple way I can explain it is this. MCP gives AI agent tools they can call. So normally when you use AI assistant, you give it a prompt. You say something like analyze this API performance problem. But the AI doesn't really know your system, and it doesn't know your runtime behavior, it doesn't know your actual metrics, it doesn't know what happens when 20 users hit your endpoint at the same time. So it guesses based on the code and the context you give it. With MCP, instead of only giving the AI text, you expose actual tools. For example, you will expose run a load test to analyze the latest results, detect slow responsive, detect thread pull observation, generate a performance report, etc. And now the AI is not just answering from memory. It can call a tool, receive real data, and reason about data. And that is the important shift. The AI becomes the reasoning layer, and your MCP server provides the real world data. So on the top we have a client or agent, Cloud, Copilot. In this case we are going to use GitHub Copilot. And then that AI client has access to MCP server. In our case, that is a .NET MCP server. So we implemented MCP server with C# code in .NET, with which you connect through HTTP, and MCP tools that we are going to talk in this video expose some tools to AI. For example, run load tests, compare endpoints, analyze results, and generate report. And our .NET MCP server will execute those tools and will show results to some other application. In our case, that is a Blazor, pure Blazor.NET application, where you can see results visualization, or in an existing .NET application. So as you can see, MCP server is just a protocol that allows you to use some tools, which in this case we are going to implement ourselves. Of course, with MCP server you can use many tools out there that already exist. In this video we are going to focus on our MCP server and our MCP tools. Let's go to the repository. Let me quickly show you the structure of this solution. We have 4 projects here, and the main project here is our API, which endpoints we are going to test. It contains a few endpoints that simulate real performance problems. These endpoints slow thread sleep, uses thread sleep. Another one uses task delay. From the outside they look almost the same. Out wait for some time to return a response. but under load they behave completely differently. Thread sleep blocks a thread pull thread and delay release the thread while waiting, and that difference becomes very visible when we run load tests. From a single request perspective, both can look fine. You call endpoint, it waits, it returns results, no exceptions, no obvious problem. But under concurrent load the difference is huge. With thread sleep, a request blocks a real thread pull, and if enough requests arrive at the same time, the thread pool starts running out of available threads, and requests start waiting, latency increases, throughput drops, and suddenly your API feels slow even if CPU usage is not that high. And that's exactly the kind of the problem that is hard to understand from code alone. You need runtime behavior, you need measurements, and this is where MCP becomes interesting. I realized while building MCP servers in .NET, most AI agents still operate without real context. You give them prompts, maybe you pay some code, maybe you describe the problem, but they usually don't understand the discussion, architecture decisions, or trade-offs that happened before the code was written. And then context matters a lot, because in real teams the important information is not always inside the code base. It's often in diagrams, planning boards, architecture sessions, API discussions, and technical trade-offs. And that's why I think workspaces like Miro are becoming really interesting. Miro has evolved into something more than just collaboration board. It's becoming a collaborative AI workflow platform. For example, during architectural planning session, teams already create a lot of valuable context. Diagrams, feature flows, API contracts, technical trade-offs, backlog decisions, next steps. Normally, that context gets spread across 10 different tools. A diagram is in one place, the backlog is somewhere else, the notes are in another document. And when AI agent enters the workflow, it often starts from blank prompt. But with Miro flows, you can turn those sessions directly into structured outputs, action plans, summaries, backlog items, implementation steps, next actions. And since everything lives in the same visual workspace, AI can work with the team's real context instead of only reading a short task description. What's especially relevant for this video is that Miro also supports MCP workflows. So you can connect AI agents like Claude or Cursor directly to the collaborative context your team already created. That means your AI agent can understand why a decision was made, what constraints exist, what architecture was discussed, what the team planned, what trade-offs were accepted, not just the final ticket. And honestly, I think this is where AI workflows are heading next. Less isolated prompting and more context-aware collaboration. If you want to explore a collaborative AI workflows or MCP integrations yourself, check out Miro using the link in the description. And now let's go back to our .NET MCP server and see how this works in practice. Let me show you the main project about MCP servers here is Performance Lab MCP server. Let's go to the program CS file. Inside the MCP server, the setup is actually very small. This is still a regular ASP.NET Core application, but the main part is adding MCP server and exposing it over HTTP. We register our services result store, load test runner, result analyzer, and then we add MCP server with HTTP transport. Also, the important line is here with tools from assembly and discover all methods marked as MCP tools. Then we map the MCP server endpoint as MCP, and that is the endpoint the AI connects to. In my case, the client connects to a local host port/MCP. That's the bridge between AI agent and my .NET application. This is the file where all tools we are going to use in this project are implemented. Now let's take a look at one tool, for example, run load test. This is just a C# method, but it has a few important attributes. It is marked as MCP server tool, and it has a description. The description is extremely important because this is what the AI reads when deciding which tool to call. So if a description is bad or confusing, the AI may not use the tool correctly. For this tool, I describe exactly what it does. It runs a load testing against an API endpoint. It accepts URL duration in seconds, the number of concurrent users, and it returns throughput, latency percentiles, error rate, and a result ID. The result ID can then be used by other tools. For example, analyze this result, compare it with another result, generate a report, detect thread pool observation, and so on. So MCP tools should be treated almost like an API contract for the AI. Clear name, clear parameters, clear output. We are just running some tests and analysis, and we are returning results. We have compare endpoints, we have analyze results, we have detect slow responses, we have detect memory pressure, compare before and after, we have generate report, and the last one is suggest optimizations. Okay, now we have our basic .NET API application and we have an MCP server. The main problem now is connect the AI client with the MCP. For that we are going to use MCP configuration file. In Visual Studio Code you can add in VS Code folder, and that is a basic MCP JSON file. Inside it, I define my MCP server. So we have one server, performance lab server, which is HTTP type server, and we have URL where this server is available. Now the AI client knows there is an MCP server called performance lab, and I can call its tools. Let's run all the applications. I will just tell my agent to run all applications. All my 3 applications are now running. You can access it through web browser. So here we have all 3 applications. This is MCP server that will call a tools. Here we have our API. For example, if you call some fast endpoint, you will get some response. And here we have Blazor application with 2 main pages. The one is results and another is compare. So currently we don't have any results because we didn't connect AI to MCP server and we didn't run load test. So let's run our first test with the AI agent. I will go back to our Visual Studio Code, and in the Copilot, let's just ask something in plain English. You can ask run a load test, some endpoint from our API, for example, slow thread sleep endpoint, and let's run it for 15 seconds with 20 concurrent users. While it's running, I want to show you how you can see this in dashboard immediately. Let's take a look in parallel with the Blazor dashboard. The load test against slow thread sleep is complete. We have total number of requests per second, average latency is 569 milliseconds, P59 latency is 1 second, and no errors. Severity medium, average and P95 latency are high. This is expected due to thread sleep blocking threads. If I go and refresh in our dashboard, you can see our load test results, and this is our last test. So if you go to the details, you can see some details. Then we have some .NET optimizations that AI is figure out there. But here's the important thing, that we have medium severity and it's worth investigating. So let's try a more useful example here. So I will ask compare slow thread sleep with slow task delay using 50 seconds and 20 concurrent users, and let's see what happens now. We have some results, so comparison is completed, and we have baseline, which is our slow thread sleep, and we have candidate. No errors for either, and what is the verdict? Slow task delay is significantly faster and scales better under the load. So you can have a detailed markdown performance report. But before that, let's refresh this one. And as you can see, there are a couple of more things we have here. Let me show this in full screen. So here you can see load test results, and you can see latency comparison between those endpoints. We have average, we have P95 and P99. Slow task delay is much faster and performs better than slow thread sleep. Here we have a compare tab. So from endpoints we already executed, we can choose some endpoints to compare results. Let's use slow thread sleep and let's use slow task delay. If we compare it, you can see metrics, you can see the baseline, which is our slow thread sleep and which is a candidate. When you compare those values, on the right side you have changes and you can see which one performs better. Okay, I have a couple of more tools, but I will not go through every tool in this video. So if you want to download this source code, down in the description you can find the link with the source code so you can test it and play with it. At the last step, would you like a detailed markdown performance report? Let's say yes, I want a report. And let's see what we are going to get here. We have a report directly in AI agent. It is the same report like we already have seen in the dashboard. So this is exactly why MCP is so powerful. The AI is not replacing your system and the AI is not replacing developer. It is operating your system through control tools. MCP is not only about this demo. This demo is just a performance test, but the same idea can be applied to many real .NET workflows. You could expose tools for checking deployment status, reading application metrics, querying logs, running database diagnostics, analyzing slow SQL queries, generating release notes, validating API contracts, inspecting feature flags, and many other things. The real value is deciding what tools your AI agent should be allowed to call, because once the agent has access to real domain specific tools, it stops being just a chatbot. In that moment it becomes a workflow assistant. For this demo the AI could run load tests and analyze performances, but in your own system it could interact with whatever matters most to your team. And that's why I think MCP is one of the most practical AI concepts for .NET developers right now. Not because it looks cool, yes, it looks cool, but because it gives AI agents real contexts, real actions, and real tools to use. So that's it for this video. As I said, if you want the full implementation, I'll leave the link in the description. And if you're building something with MCP servers in .NET, let me know in the comments, because I'm very curious to see what kind of tools developers are exposing to AI agents. If you like this video, please subscribe to the channel, like this video. See you in the next one. Dream big.